Hello, listeners, and welcome to another episode of Grey Matter Talks Tech, your go-to podcast for the latest tech insights, tips, and trends from industry experts. I'm today's host, Leanne Bevan, Vendor Marketing Manager at Grey Matter. In this episode, I'm delighted to be joined by Dr Jodie Burchell, Developer Advocate in Data Science at JetBrains. And we're here today to discuss the current landscape of data science in 2025. So hello, Jodie, welcome to the podcast.
Hi, I'm very happy to be here.
Me too. I'm really looking forward to this topic. So before we delve into data science, could you tell our listeners a little bit more about yourself and JetBrains?
Yeah, so I've been at JetBrains as a developer advocate for over 3 years now. And my background, as you can probably guess from the doctor title, is academic. So I did my PhD in psychology, then fell in love in statistics, and that ended up leading me into a career in data science. So I've been a data scientist for around 10 years now. And I always like to say I was doing natural language processing before it was cool. So before LLMs were like a big thing, we were sort of working on projects with, older methods that are a bit more simple. So yeah, been in the industry for quite a long time and seen a lot of trends coming and going and a lot of arguments being settled that, seemed very important at the time and have kind of gone nowhere. And then just in terms of JetBrains, JetBrains is a company that was founded in year 2000, actually. We've been around quite a long time. And our focus the entire time has been building tools that help developers, data scientists, other professionals working in the tech space be more productive. So in terms of our data products, the ones that I work with most closely, we have two main products. We have PyCharm, which is a IDE, integrated development environment for working specifically with Python. And we have huge amount of support for data science work, ML work, AI work in this IDE. And then we also have DataLore, which is an online platform which is more designed for collaborative work. And it also works across a variety of languages. It works with Python, it works with R, it works with Kotlin. And it has a lot of different features, again, for productivity for data scientists, analysts, and data professionals.
Well, yeah, I think productivity is really key in this day and age. We're always kind of looking for more ways to speed things up or do things more efficiently. So I think that's really useful tools that people can use. And in your 10 years in the industry, there must be so much change, particularly in the last 5 years, perhaps, in data science, which has probably been amazing to see.
Oh my goodness, yes. Yes. And I think we'll probably end up talking a bit about some of those today.
Yeah, definitely. So that brings me nicely on to our first question, really. So what is data science in 2025? Is it just AI and large language models, or are there people doing other things as well?
Yeah, so I think if you're not in the field, you're looking in from the outside, and maybe in particular, if you're someone who wants to get started in this field, it feels like it's nothing but LLMs because that's all that people are talking about nowadays. But I can assure you data science is very much as it sort of was when I started in a lot of ways, in that there's always been three main branches of data science. So you have what's called tabular data science, which is also data analysis. And that's just basically working with structured data. This is data that's in tables. So you have a bunch of columns, you have a bunch of rows, and you have numbers or text. And then there's natural language processing, and that's just working with unstructured text data. And that's sort of the field that LLMs has sort of been the latest advancement in. And then you have computer vision, and that is, unsurprising by the name, that's working with images, which is also unstructured data. So what has sort of been the big advancement since 2018 actually has been the development of a specific type of model architecture called the transformer model. And this was initially designed for machine translation, and it was the first large language model, or the basis of the first large language model. And from this architecture, a lot of models in text processing and image processing have actually been built. And this is what kicked off the current generative AI trend. And we've seen a lot of tooling evolve around that, things like Hugging Face Hub. We have proprietary APIs from companies like Anthropic or OpenAI. And it's made it possible to do a lot more with text data without necessarily having specialist skills. Although I would caution, please do learn your fundamentals about data cleaning always. You can never escape that. So it means natural language processing is having a bit of a golden period at the moment. Computer vision quietly is also having like a lot of advancements. But at its core, classic tabular data analysis and machine learning aren't going anywhere. And while I haven't been working sort of on the ground as a data scientist for a few years, we know this because JetBrains, we internally do surveys. We also help out with surveys like the Python Developer Survey. And we can see packages like scikit-learn, which are for core sort of tabular data machine learning, are still really, really popular. I think like 77% of respondents said that they were using this. So I think data science is still kind of at its core solving boring business problems because that's where you make money. And I think a lot of this NLP stuff, while it's really promising, it's probably still not the bulk of work that's being done in data science.
You mentioned some surveys there. What other key findings did you find from that? Is there any particular industries that are benefiting most from data science tools and kind of analysing data? My first thoughts are things like healthcare maybe or somewhere else.
Yeah, those surveys unfortunately didn't look into specific industries. But I do know sort of from, anecdata, it's not quite as good as actual data, but talking to people, seeing the companies that are coming up, I can certainly see that there are a lot of applications for these new technologies and things like, as you said, healthcare, like medical coding. I know someone who's worked on a project to do that. And also things like object detection. So stuff like self-driving cars or, in a slightly more nefarious way, being able to monitor crowds and things like that. These sort of applications are getting much more sophisticated and easier to do.
Definitely. And were there any other findings from that Python survey that you think are particularly interesting?
Yeah. So I think what's actually interesting, and it kind of goes back to what I was saying about, while there's been a lot of new and exciting stuff in the last few years, a lot has stayed the same, is that when we were looking at the tools that people use for data exploration and processing, 77% of people were still using pandas. So to sort of explain pandas for those who are not familiar with it, it's a very old project. It's basically 15 years old, and it was initially designed to help people process like the tiny little data sets you had on your computer 15 years ago. So it's never been a project that, like, from its fundamentals, was designed to handle the scale of data that we regularly deal with nowadays. And what's super interesting is that 77%, as I said, of respondents are still using pandas. So for me, that indicates that a lot of people are still working with what I guess you would call small data. That's not an official term, but data that can still comfortably fit onto their laptops, data that, when you process it, it's not necessarily super complex in terms of the transformations that you need to do, or if the transformations are complex, the data is small enough that your computer can handle that. Of course, that comes with the caveat that computers keep getting more and more sophisticated. So I have like a nice shiny M3 Mac, and it can handle quite a lot. But I think these predictions that we had, like, I think it's probably like 5, maybe a bit more years ago, that big data was taking over and everything was going to be moving to the cloud, it hasn't really panned out that much.
Why do you think that is? Why do you think it hasn't moved that way? Or is it still kind of in the process and maybe something that we'll see in the next 5 years, perhaps?
Probably the reason for that is the way that a lot of people work with data. So if we're talking about data analysts, like especially business intelligence analysts, what they'll often have is a very predictable set of things that they need to report on. And so for them, they will work out, okay, let's say it's sales data or it's inventory data, something like that, something really core to the running of the business. They'll work out, okay, what are the tables that they need to work from? And upstream, you'll have, say, a data engineer that will actually do that processing for them on the cloud. So it's not the data analyst that's doing that work. It's someone upstream who has experience of working with really big data. And then the end product will be these smaller tables that the data analyst can play with on their computer. In the case of data scientists, if we do need to work with big data, often what we're doing is we'll do that processing in something like a SQL server. So you'll have your data stored in a SQL database. You'll use SQL to do that pre-processing. That is essentially being done on the cloud. But then the end table you're dealing with is either a sample or an aggregation, and it's something you can handle in-house. And I'd honestly say the reason for it is it's just a lot easier. Like, it's really annoying having to set up something like a Spark session, like a PySpark session, which allows you to work with distributed computing or connect to some sort of notebook server. Unless you're working with a tool like Datalore that makes it a lot easier. And so for a lot of us, it's like the frustration of having to do all that overhead just to start working with the data. It's like, well, it's just easier to aggregate it, pull down a sample, and then when you need to productionize it, maybe you'll need to deal with the cloud.
Yeah, and that brings me nicely on. You kind of touched on it a little bit there. When it comes to data science, there are numerous job roles in the sector. Could you explain the difference between the different roles, such as you mentioned data analyst there, data scientist? There's also roles such as machine learning engineer, AI engineer, and operations engineer. Could you explain a bit more about the different roles and what their responsibilities are?
Yeah, and this is a massive source of confusion, even for people, again, who are starting in data science. So data analyst has always been and still is a very, very broad job title. So it can mean something as concrete as a BI analyst, so someone who you will employ to do your reporting on your business as usual.
Yeah.
And this is a very old job title for obvious reasons. But it could be someone who's essentially sharing responsibilities with a data scientist. And at its core, what a data scientist is a researcher. Kind of in the name. I guess that's why they call us data scientists. And the idea is, if you're hiring a data scientist, you have some sort of inkling that you might be able to get something innovative out of your data. So maybe there's some sort of inefficiencies in the way that you're doing things, and say your salespeople or your logistics people or someone like that, they have an intuition that something could be improved, but they can't see the bigger pattern, obviously, because, they're working on the ground. Or it could be you have an idea that there's some IP that you could create out of your data that you could sell. So your data scientist would be hired for that. But because data scientists are researchers, and that's why so many of us come from academia, we're generally not engineers. So what that means is, if you want to actually deploy your products, you need to work with the engineers to do this in a way that's reproducible, that's stable, that's performant. So ML engineers, it's a relatively new job title, like not new, but probably, I don't know, maybe 5 years old, a little bit older than that. And these are engineers who have sort of specialized in having knowledge of how to best deploy machine learning models that data scientists might create. And they might also be building models themselves, but generally they're specializing more on the deployment side of things. AI engineers, this is definitely a new title. This is part of the current hype wave. but they're kind of the same thing as ML engineers, but they might have more specialization in more complex large models, like large language models. Like these models are so huge that they essentially have a lot of complications that come with resourcing and performance. And then you've got ML ops engineers. They specialize in deploying and monitoring ML models. So finding resources for them, being able to do this in a cost-effective way. So you can kind of say it's not super clear, like it's a bit fuzzy.
Yeah.
It's very influenced by trends. And like I've honestly known people who, I guess you could call them full stack data scientists.
Yeah.
Like they essentially were doing data science and ML engineering work, but it's not common to find that, particularly at larger companies.
Yeah. And would you say, is there different kind of learning paths for each of those roles? You mentioned obviously your role has been quite academic. Is with the engineering now, does that still require like an academic background, or can people come through other avenues?
Yeah, I think for the engineering roles, they come much more from either a software development or computer sciences background. So it's sort of because the two jobs are both, full-fledged jobs that require very different skill sets. So if I'm perfectly honest, my knowledge on like software development best practices is relatively weak because all the code I've written in my life, or most of it, not all of it, has been for throwaway research purposes. And when it's gone into production, it's been rewritten. It's also your ML engineers, your AI engineers, they may not even be people who specialize in this. It might just be your back-end engineers or your data engineers who get co-opted to do this. And a lot of the time, they're not even going to know Python in that case. So they've written a back-end in, say, Go or Java or Rust or like a more high-performance language. And so in that case, you and the engineers need to get creative about how you're going to fit this Python model in your Rust backend or your Go backend. So definitely the skills are different. Usually the job experience will be different. And you really just have like a backend engineer working with your data scientists. The overlap is going to be not so big in terms of their common understanding. So in that case, you need good communication on both sides and like really clear specifications about what both sides need.
Yeah, definitely. And you mentioned Python there. What programming languages are people using for data science? Is it just Python, or are there others kind of coming into the mix now as tech progresses?
Yeah, so when I started 10 years ago, as I said already, making me feel old, there was this huge debate about Python versus R. And I actually started in R, again, coming from a stats academic background. But pretty much as Python has evolved, it's taken over as the most popular language for data science. We can actually see that. There's something called the tabular index. I think I've pronounced that right. Basically, it's a survey seeing like what languages are people using, what languages do they want to use. And Python is the most popular language in the world at the moment. Yes. And it's the most popular language for data science. So again, going back to the Python developer survey, at least 50% of Python users are using it for data analysis or data science related purposes. So back when I was starting, again, there were 3 languages. So I've already mentioned R. R is a language, it's still very much in existence, still very popular in academia.
Yeah.
But it was a language that was designed for small data sets with a high degree of specialization on statistics. So very kind of complex, specialized statistical models would have modules written so you could do them in R. And I think in that aspect, probably Python hasn't caught up, but it's not what Python is trying to do. Python is more about machine learning than specialized statistics. And then there's the third language that everyone always forgets about, which is Julia. Julia was, Julia is, it's still around. It was basically an idea to make a high-performance data science language. And for whatever reason, it just kind of never got wide usage. But it has still users. Those users are very passionate about it. But I don't know why. Like it feels a nice use case, but Julia just never took off.
Oh, it's a shame. And
It is a shame.
with regards to Python, you kind of touched on it with the machine learning. Is that why it's so popular and why so many people are using it? Or is it just because it's easy to use and learn?
There's a couple of reasons. So definitely the easy to use and learn is a huge factor. So Python is a very, very accessible language, and it has a strong community of sort of welcoming beginners around it. So it's very easy to find beginner-friendly events. Like I actually run one called Humble Data. I should say I'm part of the group running it. I'm not the only one, which is designed to get complete beginners into Python and basics of data science. But you can find all sorts of workshops like this around. Like it's just very easy to start in Python, and it's a nice experience if you've never coded. But the other reason is Python is a very, very flexible language. So you can actually build entire applications end to end using Python. So it's just, large enterprise applications probably aren't built in it because it's not as fast as other languages. But it's more that you're not just stuck doing statistics. You can do a whole bunch of other stuff. And then from that, the machine learning libraries just got their own traction and took off.
Yeah, it's interesting. So what are some of the changes that you've seen to data science tooling in recent years?
Yeah, so I keep talking about performance, and this has really been an awareness in the community as time has gone on, as the data we deal with is bigger, and the way we work with the tooling has gotten, I wouldn't say it's gotten more complex, but the problems that have always been there have remained and become a thorn in people's sides. So I just want to talk about two emerging projects that have come out in the last few years. So we talked already about pandas. And one of the problems, as I said, is that pandas was never really designed for larger data sets. So if you want to work with larger data sets, you need to move off your local computer and start working in the cloud. And this is a bit of a faff to set up. So a project came out in, I want to say 2022 it started, called Polars. And Polars is an attempt to sort of create a middle ground where you can do fairly large data processing on your local computer in an efficient way. And the creator of the project has built some pretty interesting stuff into it. Like you can have safe concurrency because it's written in Rust on the back end, which you can't have in Python. It has actually query interpretation, which is really interesting. So instead of just executing the transformations as you write them, it actually attempts to do a little bit of, clever optimizations to work out whether that's the most efficient way of doing things. And basically it has data types that are more suitable to the range of data that you can see in a data frame. So with the original pandas, it was only really able to handle numeric data, and anything that wasn't numeric, like strings or booleans or date times, they kind of had to do a hack to make it work. With Polars, it has native types for each of these data types. So it's just much more efficient. And yeah, it's been gaining a lot of popularity in the last few years as a project. Last year in particular, everyone was very excited about it. The other one I want to talk about is Marimo. So data scientists, they use Jupyter notebooks. So this is a particular way of working with code where you can kind of set it almost out like, it's almost like a Word document where you can intersperse blocks of text and code, or you can just work with code or just text. Like you can just make these blocks that are either text or code. And you don't have to just use it with Python, but Python has sort of become the most popular usage of it.
Yeah.
So Jupyter Notebooks are great. I use Jupyter Notebooks all the time. It's pretty much all I use. But they have a few problems. So one of them is you can just create these blocks. They're called cells in whatever order you want. But the problem is if you're being a bit messy, which happens to all of us with a big analysis, because you start just trying things out and stopping them. You might do some sort of transformation to the data in one cell and then make a cell above it and do another transformation. And then maybe somewhere else you'll do another transformation that's related to that. And everything's just jumbled and out of order because it's what kind of happens organically when you're working with them. So that's one problem. Another problem is like when you've written up your project in a Jupyter Notebook, it's really hard to then deploy it because it's just this chunk of code cells, sorry. So basically Marimo is an attempt to overcome a lot of this stuff. So it has reproducible execution. You have a much sort of less painful pathway between like creating the notebook and deploying it. And there's a bunch of other cool things, like it's designed to work with Git. So it's a lot easier to collaborate on the notebooks and version them and things like that. So yeah, it's an exciting new project and people are really excited about that this year.
Awesome. Yeah, it sounds really good. A lot more productive, I guess, and saves a bit of time. Were there any other tools or changes that you've seen as well? We've briefly touched on AI. Is that an area that's changed at all?
Yeah, and I think we'd be remiss if we didn't talk about AI tooling. I briefly talked about them in the first section, but essentially it used to be really difficult to work with large language models when they first came out. So I first started playing with large language models at the end of 2019, and the documentation around how to work with them was bad. It was really difficult to sort of get hold of these models. But this has obviously completely changed in the last few years. And the leading company that's helping distribute open source models is called Hugging Face. So I mentioned Hugging Face Hub. It's basically a platform where you can download what are called foundational large language models or foundational multimodal models or vision models, all this sort of stuff. So these really big models that companies like Google maybe have trained, or Meta, or other companies, and they make available for everyone to use for free. They get uploaded there. And then Hugging Face have built specific packages like their Transformers package. They also have Diffusers, I think is the other package, for working with these models. And this would actually be the point where I promote one of my favorite tutorials I've ever seen, which is if you're interested in getting into working with large language models in Python, you do need a bit of basic Python, but if you're interested in getting into this, Hugging Face have an amazing free natural language processing course, and it shows you how to actually use their tooling and use it for actually relatively complex use cases. So right now, it's not just the tooling, but it's also the ecosystem around documentation and showing you how to use those tools that have, massively changed the accessibility of what I guess we'd call AI.
Yeah, that sounds really cool. And it's so good that there's so many resources out there. And like you mentioned, your community group as well, that everyone's kind of there to help each other out, and really nice environment to be part of.
Yeah, it is. And I think this is also actually something that's changed a bit with data science in the last 10 years. So I would say, honestly, there were some pretty good free resources for learning data science when I started. Like Coursera, when they first started, they had some amazing specializations, like the data science specialization from Johns Hopkins.
Yeah.
But it sort of still felt a bit rarefied, and like 80% of us were like ex-PhDs, and it felt a bit like the whole tone was you need to know everything. You need to know everything about this field, and you need to be a really good programmer and blah, blah, blah. And I think everyone realized as the field matured, it's a bit unreasonable. Like, even if you can hire these people, how are you going to replace them if they leave? So the field started specializing a bit more, and everyone got a bit more realistic. And with that came so many resources for beginners and a much more beginner-friendly atmosphere. And I obviously think that's a really positive change, because if you're interested in this, you can absolutely do it. It just takes a bit of patience.
Yeah, definitely. And obviously, it's not going to be smooth running all the way. What are some of the challenges for data science projects at the moment that either yourself or people in the industry are typically having?
Yeah. So I know I've kind of actually downplayed the size of data a bit, but the thing is that there will be times where you do have to deal with really large data. So my last job, one of the reasons I wanted to work at this company specifically is because they had truly large data. So we were working in selling basically online auctions for ad space.
Yeah.
And the volume was incredible. I think we were dealing with, when I left, 170 billion auctions a day.
Wow.
Yeah.
Incredible. That's a lot.
It's amazing. I can tell you the data engineers I worked with were some of the cleverest people I've ever worked with. They were amazing.
Wow.
But yeah, obviously dealing with data at that sort of scope is really challenging. And it's funny because a lot of our tools are just not really set up for that. So there's sort of been an increasing focus on how we can actually help people work more efficiently with big data, how we can make sort of ML ops a bit more accessible for data scientists. So, like I said, data law, our product is online first, and it allows you to work with really large machines if you need to. But yeah, there's also been an increasing focus on big data tooling. So PySpark is one of the classics. This was something I was using even 5 years ago. But there's been sort of more emerging tools like Great Expectations, PyFlink, things like that. So it remains a challenge, because also part of it is, you as a data scientist need to think about, like, there's no right answer. Like, how much data do you actually need? How can you aggregate it in a way that's meaningful? I can tell you working with big data is it's frustrating. But yeah, there's an increase in tooling to try and help deal with that. We talked about reproducibility a bit with Jupyter Notebooks. So Marimo is one potential solution that seems to really be gaining traction to help with that. But there's also problems with, like, making sure your experiments are reproducible. So basically, if you train a model and then you change something, and then you want to make sure that, that result you got that's maybe better is the model that you end up using, you need ways of tracking this.
Mm-hmm.
You also need to make sure that when you deploy your models, everything can actually be reproduced across multiple different pods or servers. So yeah, still a challenge. It's still very complex. Usually you need help from your engineers to make sure that this is done. It's really important to have good monitoring. And so this, again, there's more tooling coming up to help with this, but it's also a culture thing. You really need to make sure you have rigorous work. And then obviously large language models and other large models have brought up their own problems. And one of these is it is so expensive to deploy large language models.
Mm-hmm.
So basically, I did a little calculation to sort of see how much it would cost. It was like a year ago I did this. to deploy a large language model in a way that would allow you to get, real-time responses from it.
Yeah.
And for like a medium-sized large language model, you are looking at like having to get these specialized servers with a lot of GPUs, because large language models need GPUs. And these can cost like $40 an hour to use.
Wow.
And you might need more than one. And so the current state of large language models is a bit strange, because up until January of this year, the wisdom was bigger is better. We just need bigger models. And companies like OpenAI and Anthropic were actually trying to work out how to make this economically viable, because they spend a lot of money on specialized computers to actually give you those nice real-time predictions that they give you. And then in January, a model called DeepSeek came out. And DeepSeek is a model by a Chinese company, which is much, much smaller. And it was open source, so people started making their own versions of this model quite quickly. And so now the current wisdom is, okay, we can have large language models that are a lot smaller. And this is definitely going to really solve a lot of these problems. But yeah, the older large language models are massive and really expensive to run. So if you want to run one, just be aware of what you're actually getting yourself into.
And what trends are you seeing kind of for the future? What do you think will happen? Will it kind of continue kind of plodding along with the trusted and tried methods that you mentioned at the start? Or will there be like maybe more investment into the larger language, big data, or something else?
So I think we're in, the third year of LLM hype at this point.
Yeah.
So I think maybe part of where people got confused about LLMs is they seemed like they were a completely new type of model. And I suppose this is partially because they get labeled as AI rather than machine learning. But at their core, they're still machine learning models. And machine learning is not really just the models you use. It's a fundamental approach to how you treat data. So data cleaning, making sure that models will perform just as well on the training data as they will in the real world, that models over time will still give predictions that are just as good as when you train them. This is called model drift, that, there's something changing with the data or something like that.
Mm-hmm.
So these fundamentals they'll never go away. Maybe they will. I don't want to say never, but definitely in the coming years, these solid fundamentals that the field is built on won't go away. I would say that LLMs are starting to settle a little bit in terms of the applications people are seeing for them.
Yeah.
But I think what people forget is that before the generative AI hype, LLMs already had very solid applications in things like search or in what else? What would be another application? I use them in search. This is why I'm stuck on this, but I'll stick with search for now. It had other applications.
Yeah.
Basically, Google actually first developed these models, and obviously they were using them for search. So it's not that LLMs are going to go away. I think the applications of generative AI are in some ways a bit specialized and a little limited because the models hallucinate and you can't just let them produce things without a certain degree of supervision. I do think that they have potential for code generation, and obviously my company has their own AI tools for code generation, but
yeah,
I strongly believe that this is a good use case because it has a strong degree of supervision. And yeah, just in terms of the backbone of the field, like those problems to optimize logistics delivery paths or try to work out if these customers are actually valuable, or trying to see if there's new audiences that we can market to.
Yeah.
Those problems are never going to go away. So core data science, I think, will just stay with its tabular backbone. And yeah, I think maybe we'll just see a few of these generative AI markets disappearing over the next year or two.
Yeah, thank you for that. Really interesting. Before I wrap up, I have an additional question to ask. Here at Grey Matter, we've touched on kind of women in the tech space. We ran an event or a round table last year, and I'm just intrigued on your own experience of what you see in the industry with data science and women in tech. Are you seeing more take up of women starting to use data science and go down that career path?
Yeah, data science has actually been always an interesting subfield within tech, in that it always has had more women in it than your general developer background. So I'm not going to say like I haven't been the only woman on the team quite a few times. But because data science, so I would say sort of like the educational pipeline for traditional software development, let's call it that way, is usually computer science or software engineering or IT degrees. These are strongly male-dominated degrees, and for whatever reasons, I'm sure there's many complex societal reasons, women do not go into these degrees at the same rate as men, nowhere near. And I'm sure that, you know, being the only woman in a degree can be uncomfortable as well. So maybe the dropout is higher. I don't want to speak for all women, but, you know, maybe these are some of the factors. But data science, actually, people come in from a much more varied background because, again, a lot of us are ex-scientists. So my background is quite weird. Like, you don't see many psychologists that end up transitioning into data science. But there are a lot of, like, say, ex-environmental scientists or biologists or chemists, and then obviously physicists, mathematicians. But because of that, you get a lot more women coming in the pipeline. So I think it's also, I don't know, it's also Python. Python has really made a strong effort to be an inclusive community for everyone, to the point of having codes of conduct that, you know, if someone says something sexist to you, you can report them and they will not be welcome at a conference again. And so I don't know, I'm not saying it's perfect. I'm not saying it's a solved problem, really far from it. But I definitely see that if you can get the pipeline where women feel encouraged to go into these fields earlier, and you can then foster communities that make it really clear that you belong here and you have a space, that's, I think, a way that we can increase diversity.
Yeah, for sure. And yeah, it's really interesting. You mentioned there as well, you came from a psychology background. So what drew you to data science and transitioning to that?
Do you know, this is probably the question people ask me most.
Oh, really?
Yeah. Because it is so weird, right? So in Australia, because psychology is a pipeline for registered psychology professions like clinical or organizational psychologists, all of the degrees are standardized. And in Australia, the way that we have classified psychology, it is as a behavioral science. So probably around a third of the units I did as part of my degree were statistics, research methodology, psychometrics, which is the science of measurement. And I just, I loved it so much, actually, that I ended up doing a second degree in biology. So for me, like, actually, one of the big passions in my psychology degree was statistics and research. And I just wanted to do that forever. So obviously a PhD is a whole bunch of statistics and research. And when I got out of my PhD, I actually did another 2 years as a postdoctoral fellow in biostatistics. And then when I decided to leave academia, data science was heating up. So it was not super easy. I really don't want to like gloss over how much work it was, but it was a matter of kind of just patiently reskilling and ending up finding a really good job where they sort of, my boss actually was very kind of good at socializing me from academia to industry. And yeah, from then it was just a matter of filling in any gaps I had and then bringing knowledge that I was specialized in and using that.
That's really interesting. That's cool. Yeah. I think statistics are so important. And look, we use it so much in our day-to-day life or in our careers and roles now. Like analyzing everything is at the forefront, I think, of most companies now, because they want to know how to be better and like what's working, what isn't working, why is this happening. And I think it is kind of the way forward. And data science, I think, as an industry will probably continue to grow, as you touched upon.
Yeah. One thing I would say is if you're interested in starting in this field, it is a bit of a difficult time because data science got so popular that a lot of people ended up doing boot camps and degrees in data science. And now a lot of those graduates are looking for jobs. But look, if you have a passion for the field, if you're interested in it, my advice would be like, work out what you like about it. Do you like the analysis side or do you like the building side? And, you can also think about going straight into data science or thinking like, maybe I actually want to be a BI analyst or a data analyst. Maybe I want to be a data engineer. So there's plenty of jobs in the space. It's just right now, it's a bit of a tricky time for junior data scientists, but like in the data space, there's still plenty of work to be had.
Some really interesting points here. Thanks for sharing. Is there, before we kind of wrap up, is there anything else you wanted to share around data science or projects or any use cases?
I think the thing I'm going to say is going to be very eat your vegetables and boring, but I think like when you first start reading about data science, there's like a well-known statistic that circulates. It's like 80% of the work you do is data cleaning. That is true. And getting to know your data, understanding patterns in data, understanding when things don't look right in data, like, maybe you can spot something that seems like maybe the data will be biased. These skills will never, ever lead you wrong. And if you're looking for an entry point to get into data science skills, don't feel like you need to start with like really complex models or anything to start with. Like that will all come. Start with your fundamentals, like really learn how to sample data, how to clean data, and how to understand things like bias and other things that can mess your models up. And you will have those skills and they will be useful for the rest of your career.
Thank you for sharing that. So I think that really nicely wraps up our conversation for today. So thank you so much for joining me, Jodie. It's been a really interesting topic to discuss.
Yeah, it was my pleasure. And I've had a lot of fun. Thank you so much for having me on.
Thank you. Yeah, you covered so much today. I particularly found the stuff around the different job titles really interesting, and also kind of what data science is today and how you touched upon there's still like the fundamentals are still just as important and key as much as the fancy kind of AI stuff that everyone was talking about. So for those listening, Grey Matter's a JetBrains Platinum reseller. We've been a partner of JetBrains for over 20 years now, I believe. So if you're ever in need of JetBrains data science or other licensing or tools, trials, demos, anything like that, please do get in touch with us and we'd be happy to help. And likewise, if you have any questions for Jodie or us, just get in touch with us. You can email info@greymatter.com and we'll pass any questions on to Jodie. We'll also share some of the links to the reports and some of the things that we discussed today on our website so that you can find more information about all of that. Thank you ever so much for tuning in. We've got lots of exciting topics ahead, so make sure to subscribe to not miss out. Thanks again. Bye-bye.